Yeah, this is Terry. In the last class, we have seen the indirect ELISA. The previous class, we have discussed the basic principle about the ELISA. Okay, today we are going to learn about sandwich ELISA. So we all knew what is sandwich, right? We used to have sandwich. So something is related with that kind of structure is related with this ELISA technique. So that's why the name has given. Okay, why this sandwich ELISA is much important than other ELISA? That's the reason. It's very sensitive technique, and the quality of the technique is much higher than indirect, direct, and competitive ELISA. Okay, why we need ELISA? That's a very big question. What we can do, the applications. If you have any disease, we can detect through ELISA. Even we can quantify the hormone level in your body. So for that we need certain techniques, right? So for example, you have infected with any antigens, the foreign particle. So those antigens can be easily detected through this technique. So easily we can say whether you are infected with certain virus or bacteria or whatever. So that's the reason we need this ELISA. Okay, we know the basic principle. Now I'm going to draw. Okay, now I'm going to draw the micro titer plate. Okay, the micro titer plate. Even in the indirect ELISA, we have drawn this. As we discussed, it has 12 wells this side and 8 wells. So altogether 96 wells. So we call 96 well plates. This is the name. Okay. Now I'm going to take only one. I'm going to take only one well outside. I'm going to draw this. Okay. As we discussed, in indirect ELISA, I told you in indirect ELISA, we know antigens was fixed. But in sandwich ELISA, the monoclonal antibodies will be fixed by using buffers, coated buffer. Okay, now for example, now you have the blood sample, you take the serum out, now you just add it here. Now, if you have A antigen in this sample, we want to know whether this A antigen is present in this sample or not. Now, these antibodies are very specific to this A antigen. So these antibodies can easily attach with these A antigens. There are several epitopes in each antigens. So once I add this antigen into this well, what will happen? This antigen will come and attached in one epitope. There are several epitopes in these antigens. So this one epitope will come and attached with one anti-A antibody. Okay. Now it will attached. Now what we'll do in the next step, we will wash. The reason, not only A antigen, there will be B antigens, it can be C antigens. So we are not interested with this certain antigens. We are only looking for the A antigen. So the A antigen will be already fixed or attached. So we don't need these other antigens. So what we do, we will wash. We call washout. We will wash out with washing buffer. So once you wash, all the unwanted, maybe unbounded antigens will be removed. Now what we'll do next, we call targeting antibodies. There are also monoclonal antibody. What we'll do, I already told you, it has different epitopes in the antigen. For example, if it is an antigen, it can be different epitopes. So already one antibody already attached with one epitope. Now I'm going to add the targeting antibody. So once I add the targeting antibody, it will come and attached with this antigen. So now you can see it looks like a sandwich. Two antibodies are present. In between you can see the antigens are trapped. So it's like a sandwich. So that's the reason we call this a sandwich ELISA. Now what will happen? I'm going to add another antibody, that is we call secondary antibody. We know we have discussed enzyme linked immunosorbent assay. So obviously the secondary antibodies will be linked with enzymes. Am I right? So this secondary antibody will be placed again here. This as enzymes. So this antibody will attached with the targeting antibody. The targeting antibody is attached with a certain specific interested antigens. This antigens is attached with the fixed or coated these antibodies. So now the next step, again we will be washing to remove unbound secondary antibodies. So if anything unbounded, not attached, that should be removed. So again the washing step will be occur. The next step, we will be adding the substrate. We will be adding the substrate. This substrate we call chromogenic substrate. As we discussed, always substrate can react with enzymes. Substrate can react with enzymes. It will produce a colored product. A colored product. So if you see this well, you can see some blue color productions will be there. If the color production is there, we know there are some reaction has happened inside. So the interested antigens will be there in the well. So by seeing this color product, next we use spectrophotometry. By using the spectrophotometry, we can quantify how much of antigen or antibodies are present in this well, as well as we can identify whether the interested antigen are present or not in this well. Okay, again I want to summarize. In the 96 well plate, the antibodies will be coated by using coating buffer. Once we added the antigen, the interested antigen from the serum sample, that will attached with this antibody. Again we will be using targeting antibody to attach again with this antigen to make sure a good quality result. And then we will be using enzyme linked antibodies to quantify by using the substrate. So once we add the substrate, it will react, it will produce some colored product. By using those colors, we are going to use spectrometry. Through the spectrometry, we can easily analyze quantitative and we can detect. Okay, and there are few advantages in this technique. The one is very sensitive. You can get a very good accurate result. Even you can quantitatively analyze the hormone level, all the FSH, estradiol, etc. And the second advantage of this, you can straight away use your serum sample into this technique. You don't want to go for any purification techniques because these two antibodies are very specific to the different epitopes of these antigens. So you don't need any purification techniques, straight away you can go for it. But what is the disadvantage? you should thoroughly know about interested antigens. So according to that, you have to make your antibodies where it can bind easily. So this is the outline of ELISA. Any more doubts? You can comment on section. Thank you.